Hello! In this video we're going to see how to create a Pygame surface. In particular, our display surface, which we'll treat as our game window. So this is the thing that's going to open up when we run our program. So it's crucial that we understand how to do this. Then we'll discuss the importance of the game loop, which is a kind of like pivotal concept, I think, in video game design. So I have Visual Studio open here. I'm going to create a new file, so File, New File. And the first thing that I want to do is I want to save my file so it's associated with Python. So I can do Control S to do a quick save here. And I'm going to take a moment here to just kind of stress the importance of organization and file structure. So I have a dedicated folder here for this course, my Pygame course, and I've got a dedicated subfolder here for all of the basics that we're going to do. When we make our games, we want to make sure that our Python script and all of our assets are in the same directory. It's just going to make life a lot easier for us as we move forward here. So kind of the organization and the structure that we use is going to be really important. So in here, this is my first file, so I'm going to start with a 1 underscore, and I'll call this display underscore surface. And then I'll give it the .py extension so that Visual Studio knows that this is a Python file. So I'll click Save here, and you can see right now we can tell that it's a Python file, and there's the little Python icon that's been loaded up. Okay, awesome. So now we're all set here. So the first thing that we're going to do is we're going to import the Python library, or the Pygame library. So we'll do import Pygame. Now it's crucial that we initialize Pygame. This will initialize all imported Pygame modules and hopefully prevent any errors for us. Now you can initialize individual modules separately, like as you need them to kind of speed up your program. But for the purposes of our games, we're gonna, create, I think, maybe just more simple games here in the beginning. We'll initialize them all right at the beginning to prevent any and all errors. So let's see. We'll say initialize Pygame. And to do this, we just type in the name of the library, pygame.init, and we can initialize that here. Great. Now let's create a display window. This will be the game window that opens up and holds our game. We often think of programs that open up on a computer as like a window, right? But in Pygame, it's better to maybe think of them as a surface. A surface object in Pygame can be used to represent any image that we can then draw on. So Pygame has a single display surface that is contained within a window that will open up. Once you create the display, you treat it just like a surface object, meaning you can then draw on it. So we can draw like characters in our game, like a player or an enemy. We can draw scores and text, and we can draw backgrounds. So let's do that right now. So I'll put a little comment here, create a display surface, and set its caption. So first, we're going to declare a window width and height. I'm going to use uppercase here to signify that these are constant variables that will not change through the scope of the program. In fact, we're going to use constant variables quite a bit in our video game designs here because I like doing this. We can use these constant variables and then tweak them, and it should drastically change the gameplay of the game. So I'll start with window width, and make sure we spell it right, window width, and I'll set this equal to 600 here, and I'll do window underscore height, and I'll set that equal to 300. All right, perfect. Now, to create my display surface, I will call pygame.display.setMode and then pass in these window width and window height as a tuple. Of course, I want to be able to use this surface, so I'm going to have a variable here. I'll call it display surface. And I'm going to set it equal to the following call, pygame.display.setMode. And inside here, we have to pass the window width and window height as a tuple. So I need a second set of parentheses here, and I'll say window width, comma, window height. Okay, perfect. So if we run this right now, let's see what happens. So if I run this right now, the window pops up, and then it closes, right? So it opens up and then it closes, which is definitely not the behavior we want for our game. And this is because we haven't created a game loop yet. Our game loop will be a loop that continually runs as long as the game is active. And this will essentially keep our window open. So how do we do this? Well, let's see. We'll put a comment here. I'll say the main game loop. We'll start by initializing a Boolean variable called running, and we'll set it to true. So we'll say running equals true. Next, we'll use a while loop to loop as long as this variable is true. So I'll say while running. And now what do we want to do? Well, For now, I'm just going to put pass here. All right, so I'm just going to put a pass, and so nothing will happen. And so if I run this now, my window should stay open, and it does, which is great. But I can't really do anything. I can't move it. I can't close out on it. Oh, it did close out. How did that happen? There was a warning message. What did the warning message say? Let's see. When I tried that. So see, I'm trying to close it, and it says Python is not responding. So it's really not good behavior. So I'm like closing the program here. Uh-oh, there we go. Okay, so we definitely don't want that to happen. And the reason why this is happening is because we're sort of stuck in an infinite loop right here, okay? I need to have some sort of break condition. In particular, whenever the user wants to close the window or, press the mouse button at the X that's in our game window. And so any sort of pressing of a mouse button or a keyboard key in Pygame is considered an event. All right, and we can get a list of all of the current events by calling pygame.event.get. All right, so let's just take a look here. So I'm going to put a comment. I'll say loop through a list of event objects that have occurred. So to do this, we're going to use a for loop. So we'll say for event in, and now I'll call pygame.event.get. And so right here, this is going to return a list of events that are sort of stored in a queue. All right. So these are the events that have happened on this iteration of the while loop. And it's going to empty them out of this queue, and it's going to put them in this list that we can then loop through. So let's look at some of these events. So I'll say here, I'm just going to print event for right now. So let's look at some of these. So we'll run this and we'll see what happens. Okay, so right now you can see right here I'm moving my mouse. So I've got mouse motion events. I just pressed a button, so we have mouse button down. There's mouse button up. All right. Let's see. Mouse wheel. You can see mouse wheel there. I have a key down. I'm pressing keyboard keys now. Key down, key up. Key down, key up. Okay, so we've got key down, key up events. And in particular, if I come over here and I hover, that's kind of cool. Window leave, window enter, window leave. Okay, window enter. And if I hover over the X here and I click X, you can see that a quit event has just occurred. Okay, so that the event here that we're looking for when we want to close our window and maybe end our loop, break out of this game loop, is the quit event. So we can use that here. So I'm going to actually stop my program. All right, so Pygame doesn't crash again. And what I'm going to do here is I'm going to say if the given event that's in the queue, right? So the given event that we're looping through, if the event.type is equal to pygame.quit. All right, if it is a quit event, then what are we going to do? If it's a quit event, then we want to break out of our while loop. Well, to do that, we're simply going to take our Boolean running and set it equal to false. All right, so now if we run this, we should be able to, all right, we're getting all of our events. We can close out of our window. Perfect. So we have some really basic functionality here. We can open a window. We can close a window. So this is really great. One last thing that we should do here is after we break out of our while loop, I'll put a comment here, end of the game, we will uninitialize any of those Pygame modules that we initialized earlier by calling pygame.quit. And I think that's really good practice here. Lastly, I can give my window, you can see I put up here, I've had create a display surface and set its caption. I can give my display surface a caption. And so why don't we give our window the the standard hello world, because this is our first program. We'll give it hello world as our caption. So to give a caption, we'll say pygame.display.set caption, and then inside here I can pass a string, and I'll say hello world. All right, so let's run this now, and we should see everything working nicely. Here's our window. It says hello world here. We're printing out all of the different types of events we can have, whether they're keyboard presses or mouse actions, and we are looking for a specific event type, the quit event, which just happened right there, and it closed out of our window by breaking our game loop. Awesome. I think this is a great place to stop. We've seen how to create a display surface, start a game loop, and we've begun to learn about events in Pygame. We'll build on these concepts in our next video. I'll see you then. Now that we know how to create our display surface, let's learn how we can draw onto this surface. Pygame gives us basic geometric functionality to draw things like lines, circles, rectangles, etc. We can also use a wide variety of colors to draw, specifying each color as an RGB tuple. If you're unfamiliar with an RGB tuple, it's a tuple with 3 values, each ranging from 0 to 255. The first value corresponds to how much red you have, the second how much green, and the third how much blue. And so we'll see this in action momentarily. So let's open up a new file. I'm going to save this again in my same directory I was in before, basic Pygame, and I'll call this 2, and we'll call this drawing on display.py. Okay, and so we'll begin by importing Pygame and initializing Pygame. Or, yep, import, so we'll say import Pygame, and then we will initialize Pygame, just like we did before. So I'll say initialize Pygame, so we'll do pygame.init. All right, next, let's create our display surface and set its caption. So we'll say here, create a display surface and set its caption. All right, so I'll make a window width, and I'm going to set this equal to 600 here, and I'll make a window height, and I'll set it equal to 600 as well. And now I'm going to grab my display surface, so display surface is equal to pygame.display.setMode, and inside of here I'll pass a tuple of the window width and the window height that we just previously defined. And lastly, let's just give this a caption. So we'll say pygame.display.setCaption, and we'll give the string drawing objects. Okay, now let's add our game loop just like we sort of did before, right? So kind of a good review of the things that we looked at in our last video. So we'll say the main game loop. So we know we need a Boolean running. We're going to set it equal to true. That will control a while loop here. So we'll say while running, what do we want to do? Well, we're going to look, right now we're just going to constantly check to see if the user wants to quit. So we'll say for event in pygame.event.get. So remember, we're going to get all of the current events that have happened on the iteration of the loop. We're going to get them out of the queue and put them in a list, and we're looping through them, all right, with event. And we're going to check if the given event in this loop, if event.type, if its type is equal to a quit event, so pygame.quit. Then what are we going to do? We're going to set running equal to false. So that'll break us out of our while loop. And then the last thing we'll do is we'll end our game here, end the game by uninitializing all those modules that we initialized by calling pygame.quit. Okay, so there we have it, right? We just kind of quickly went through what we did in our last video. So now let's dive into what we're going to be doing here new. So above my game loop, right here above my game loop, I'm going to define some colors as RGB tuples. Again, I'll use capitals to indicate that these are going to be constant variables. All right, so let's come here and I'll just say define colors as RGB tuples. So we'll start with black. All right, so what is black going to be? Well, black has nothing in the red channel, nothing in the green channel, nothing in the blue channel. Let's do white next. What does white have? Well, white is the presence of all colors. So white has everything red, which is 255 in the red channel, 255 in the blue channel, or green channel, 255 in the blue channel. Let's do red next. Red is going to be 255 in the red channel, so that's like completely full. Nothing in the green channel, nothing in the blue channel. Let's do green. Green is going to be nothing in the red channel, 255 in the green channel, nothing in the blue channel. Blue will be, you guessed it, nothing in the red, nothing in the green, but 255 in the blue channel. Let's do yellow next. What is yellow going to be? Well, yellow, if you think about it, yellow is a mixture of red and green. So it's going to be 255 in the red, 255 in the green, and nothing in the blue channel. We have cyan, which will be, let's see, cyan is going to be green and blue mixed together, so no red. So we got 255 in the green and 255 in the blue, and we can have magenta, which is going to be red and blue mixed together. So 255 in the red, 0 in the green, and 255 in the blue. Now, I don't want you to think that you can only have values of 255 and 0 here. You most certainly could like take something and like make different shades of these colors, right? By like, I don't know, if we put this at like 100 and this at, I don't know, like let's make this 42. All right, that's going to be a different shade of a color. Might not be yellow. I don't know what it would be, but You can have any integer value between those. So perfect. So now we have our colors set. So the first thing that we can do here is we can change our background color from black to something else by calling the display surfaces fill method and passing in a given color. So right, I mean, if I run this right now, we should just have that like black window. So there's our game window, right? So maybe I want to change the background color. So let's do this. So underneath here, I'm going to do this before my game loop starts. I'm going to say give a background color to the display. So I can type in, remember we named our display here display surface. So I'm going to call display surface dot fill. So I'll call the fill method on here. And I'm going to pass in the given color. Well, we've defined all of our colors right here as our constant variables. So we have blue. Awesome. So let's run this. And if I run this now, the background is still black. Why? Well, it's because changes are not happening immediately on screen, right? Changes are not immediately visible on screen. So what we have to do is we somehow have to tell Pygame that we've made a change and we need to update the display. And you can choose one of two ways to update the display. You can either call pygame.display.flip or pygame.display.update. And they are essentially the same, except that calling flip updates the whole screen always, while update gives you the ability to update only a portion of the screen if you so desire. And so I'm going to use update, I think, for the purpose of this course. So we need to update our display. And we're always going to update our display inside of our game loop, right at the end of our game loop, so that every time the loop runs, and maybe while this loop is running, scores are changing, characters are moving, we're going to update the display. So right now it's not going to do any of that. It's just going to change the background color, but we'll put in a little comment here. And I want to make sure it's not inside of my for loop where we're getting all of our events, like our quit event. So we'll say update the display. And so to do this, I'll type pygame.display.update. All right, and so now if we run this, we should see our nice blue background. So let's give it a shot. Hey, look at that. It's beautiful, right? It's a beautiful blue. Beautiful blue. Great. So now let's draw some geometric shapes on our display too. So we can draw lines. So I'm going to come back here outside of my main game loop. All right, and so I'll put a little comment. We'll say draw various shapes on our display. So I'll put a line here. And I'm going to put in the comment here what we have to give as parameters to draw the line. So we need a surface, we need a color, we need a starting point, we need an ending point, and we need a thickness. All right, so how do I draw this line? So I call pygame.draw. And then I specify .line is what I want to draw. And inside of here, I have to pass these following arguments. So the surface that I want to draw onto is my display surface that I've created, right? So it's this thing right here. I want to draw onto that. So I'm going to type in display surface. Let's make a color. We have to give a color. So let's make red. We'll pick red. Of course, if you don't define your colors, you could always put in the tuple 25500 right here, okay? There's nothing wrong with that. I just like defining my colors, so I'm going to say red. I have to pick a starting point, so I'm going to pick the point 0, 0, 0, okay, x-coordinate, y-coordinate as a tuple. And the ending point, I'm going to pick 100, 100, x-coordinate, y-coordinate as a tuple. And then I got to give the thickness, so I'll give a thickness of 5. So this should then draw a nice red line for us. So let's take a look. And there we have it. Okay, so that looks pretty good. There's our red line. Let's draw another line. So I'll do one more line. So we'll do pygame.draw.line, and we're going to pass in our display surface. All right, what color should we make this? Let's make this green. I'm going to start this at 100, 100, so right where the other line ended. And I'm going to make the slope different. So I'm going to give it the ending point of x-coordinate 200, y-coordinate 300. And I'll give it a thickness of, I don't know, 1 here. All right, so now we should see 2 lines on the screen. And we do, perfect. So you can see different slope, different thickness. Excellent. We can draw other shapes too. So let's draw some circles. So I'll do circle next. So I'll put a little comment here, circle. And what do we have to give the circle? Well, it needs a surface, it needs a color, it needs a center of the circle, a radius of the circle, and a thickness. But I'm also going to put here, you can put 0 to fill the circle completely in. So to draw this, we're going to do pygame.draw.circle. And inside here, we need to pass a surface, which is going to be our display surface that we created. A color, let's make a white circle. A center, so I'm going to do a center of 300. You know what, let's do a center of right in the middle of our screen. So how would I do right in the middle of our screen? Well, I've got our window width and our window height. So I can use those. I'll do window width divided by 2 and window height divided by 2. If you notice, I'm using like what's called floor division or integer division. If you only did one division here, depending on what your window width and height are, you could get a decimal value. And I think you can't use decimals here, so they got to be integer values. So that's why we're going to do 2 division signs here, which will give us like floor division. So if the answer is like 1.5, it'll actually just round it down to 1. Then we need a radius. My radius, I will set it to be, let's set the radius to be 200, and I'll set the fill to be, let's set the thickness to be 6. All right, so let's check this out. Hopefully we have a circle that's like centered in our window now. Hey, look at that, and there it is. So it's centered quite nicely. Now let's draw another circle. Let's just do one more. So I'll do pygame.draw.circle, and we'll pass in our display surface. This time I'm going to make it yellow. The center will be, again, let's center it at window width divided by 2 and window height divided by 2. But this time, the radius isn't going to be 200. Let's make the radius, I don't know, 195. And we'll set the fill, the thickness to be 0, so it fills it in nicely. So let's see what this looks like. Ooh, that's kind of cool. It looks like the sun. Yeah, that's pretty neat. Okay, that looks great. Let's just go over one last geometric surface we can make, and that's the rectangle. And this one's going to be pretty important for us. Rectangles, or what they like to call them rects, are crucial in Pygame because we can use rectangles to sort of outline images, and we can use those outlines to sort of detect collisions. And that's something that we're going to use a lot moving forward. So I'll say the rectangle. What does it need? It needs a surface. It needs a color, and then here it's a little confusing. It needs a as a tuple here. It needs a top left x, a top left y, a width, and a height. So to me, that's not like really intuitive. I would think you'd like have to give like the points, but it just wants the top left corner and then the width and height of the rectangle, which it works. It definitely makes sense. So we'll call pygame.draw.rect. All right. So again, rectangles are called rects here. We'll pass in our display surface. We'll pass in a color. So I'll make this cyan. And so now the top left and top right coordinates. So, and I got to do this as a tuple. So my top left coordinate, I'll make it, I don't know, 500. My top y coordinate, I'll make it 0. And then I'll give a width of 100 and a height of 100. So essentially this should make a square, right, if the width and the height are the same. So if we run this, we get that nice square in the upper right-hand corner. So that looks pretty good. And let's do one more here, and then we'll maybe call it pygame.draw.rect. We'll pass in the display surface. We'll make it magenta, and we'll put it right below our other one. So 500 is the left corner. Now the top left of the y corner, I'll make it 100. So it's going to be right below my previous one, right? Because this started at with a y coordinate of 0, and then it went to 100. And let's make it an actual rectangle. So its width will be 50, and its height will be 100. All right, so let's check this out. All right, and so there we see it. And so now you can see that we kind of have that rectangle right here. I should mention here really quickly, so we're passing in coordinates. This, in Pygame right here, the top left coordinate is 0, 0. And as you move across horizontally, your x coordinate increases. So this is like 0, maybe this is like 100, 200, 300, 400, 500, and 600. And as you move down, the y coordinate increases. So if this is 0, this is like 100, 200, 300, 400, 500, 600. So, that might be a little bit different than what you're thinking. That it's odd that as you go down, the y coordinate increases. Okay, so I think this is a great place to stop. We're beginning to see how we can draw to our screen, and we're updating our display in our game loop. This is a good place to stop here. I will see you in our next video. Oftentimes, we don't just want geometric shapes in our games, but rather actual images that have been created from other resources. And we can most certainly use these resources in Pygame. So let's open up a new file, and I'll save this in my same directory. I'll call it 3, and we'll call it blittingimages.py. And we'll get into what blitting is in a second. So I'm going to start with our basics, just like we've been doing. So we'll import Pygame. Here I'll initialize Pygame, so we'll call pygame.init. We'll create a display surface by specifying the window width. I'll make it 600 here, and the window height, I'll make it 300, and we'll grab our display surface now. So display surface is equal to do this, we call pygame.display.setMode, and we'll pass in as a tuple the window width and the window height. And now let's set our caption. So we'll say pygame.display.setCaption, and we'll just say blitting images. Okay, perfect. And now we need a main game loop, right? So we need our game loop. So let's add that right now. So we'll say the main game loop. We'll use a Boolean running, set it equal to true. And we'll say while this Boolean is true, so while running, let's just check to see if a user wants to quit. So we'll get an event for event in pygame.event.get. Remember, these could be like key presses, mouse movements, but we want the one that is going to be the quit type, right? So we're going to check if event.type is equal to pygame.quit. Then what do we want to do? We want to make our Boolean running false. That'll break us out of our while loop, and so now here we can actually quit the game. So we'll say end the game by uninitializing all of our Pygame modules, so pygame.quit. Okay, so there we go, right? Good. We need to really fully understand that, so that's why we're typing that out each time. So now that we have that, we need to add some images to our game. So we got to go get them. So I have two image files, dragon left and dragon right, associated with this video that you can use. So you can download them right from the video. But let me show you where I got them. So I'm going to come over here to my browser, and I'll go to icon archive that I had mentioned before. And I'll just type in dragon, and I'll search. And so I want to make sure, it's really important, right? If I like, I don't know, if I like, I don't know, like this dragon, can we use it? I don't even know. Let's see. This is allowed. So, it's really important that you always check the commercial usage to make sure that you can use them if you plan to do something with your game or your program. If you're just making this for yourself, feel free to use whatever you want, right? But you don't want to go against like copyright infringement. So I often like to click commercial free here. And here is the dragon that we are going to use right here. And so it's commercial usage. It is allowed. So you definitely don't want to you want to make sure that you, you don't go against some creators like copyright. So you want to only use resources that you are able to use. So if you like this, you can download it. I'm using a 64 by 64 pixel one, but you can just download right from the video here as well. Okay, perfect. So now that I've shown you that, we're going to make sure that your image assets are in the same directory as your script that you're working with. So here we have dragon left and dragon right. Now, adding an image to our game is sort of a multi-step process. First, we're going to load our image as a surface object. So let's do that for our dragon left image. So I'm going to come here, and this is going to happen outside of my game loop. So right at the top of our code is where we're kind of doing all of our setup, our loading of things, and then here in our game loop is where we're going to actually run our game. So we're going to say create images, and so How do I want to say this? I'm gonna actually put a little comment here. So we'll say this returns a surface object with the image drawn on it. Okay, and then I'll say we can then get the rect of the surface and use the rect to position the image, if that makes sense. If it doesn't make sense, I will hopefully explain it soon. So first, let's load in our image. So I'm going to call my image dragon left image, and I'm going to set it equal to load an image, we'll type in pygame.image.load, and now we have to specify the path to our image. Well, since it's in the same directory, all I have to do is just name the image. So dragon left, and I have to give the file extension .png. Okay, perfect. So we've now loaded our image. Now we have to be able to access this surface image's position coordinates. Otherwise, Pygame won't know where to put the image on our display. And so we can do this by getting the rect, or the rectangle that surrounds our image surface. So remember, Pygame uses rect objects to store and manipulate rectangular areas. And a rect can be created from a combination of, left, top, width, and height values. Rects can also be created from Python objects that already have a rect or have an attribute named rect, such as our image surface. So calling getRect, the getRect method on a surface, returns a new rectangle that covers the entire surface. This rectangle will always start in the upper left corner of our surface and with a width and height the same size as the image surface. So I'm going to call this, I'll say dragon left rect is equal to, we're going to take our surface object, which we just created, which is this image. So dragon left image, and we're going to get the rect. So we'll call it get rect on this. So now I have a rectangle. So I have an image, this is the surface, and I have a rectangle that sort of surrounds the entire surface. And I can use this rectangle to position my image now. So let's position it. So I'll say dragon left rect dot, and I'm going to position it with top left, I'll say. And I'm going to put it right in the upper left hand corner of my window. So 0, 0. Now, you can position rects in a variety of ways. You can use top, you can use bottom, you can use left, you can use right, you can use top left like I did here, you can use top right, bottom left, bottom right, center, you can use center X, center Y. There's tons, and we'll see all of them through the scope of these videos. But for now, I'm just going to use top left, and we'll put it in the top left corner, which is going to be this coordinate 0, 0. Great. So let's do something quickly again for our right dragon image. So I'll say dragon right image is equal to pygame.image.load, and I'm going to load in dragon underscore right.png. So there's the path. So that gives me a surface image, right? An image surface. But I want to get a rectangle that it sort of surrounds that, so I can use the rectangle to position the image wherever I want. So I'll say dragon right rect is equal to, I pass in my surface, dragon right image dot get rect. So now I have a rectangle that completely covers my image surface, and now I can use that rect to position the image surface. So dragon rect, or dragon right rect dot, and this time let's use top right. So we're going to put it in the opposite corner, right? So I'm going to put this in the opposite corner. So I'm going to use the right side of my rect now, and I'm going to put it at window width all the way at the end of my window, and the y coordinate will be 0. Okay, perfect. This looks great. So let's try running this. Let's run this and see what happens. So if I run this, our window opens, but our dragons, they're not showing up, right? And why is this? Well, we kind of saw this before, right? We have to update our display. So we're updating our display inside of our game loop. So let's update our display. So I'll put in here, I'll say update the display, and this will be outside of this for loop, so I'll call pygame.display.update. Okay, so now I'm going to update the display, so maybe now our dragons will appear. And they still don't. Why? Well, it's because we haven't yet drawn them to our display surface. And let's be honest, we're not really drawing the dragons, right? The dragons have already been drawn for us. What we're doing is we're copying the dragons to our display surface. And in Pygame, copying to a surface is known as blitting. So hence the name of this, this script here, blitting images. So to blit, you call the display surface's blit method. And so when we call the blit method, we have to pass in a surface, in our case, an image that we want to blit, and then the coordinates where we want to blit it. This isn't a problem because we've already defined our surface right here, dragon left image, there's our surface, and we've already defined the coordinates right here, dragon left rect, right? We've positioned this exactly where we want it. So inside of our game loop, let's actually blit or copy our dragons. So in here I'll say blit, and I'll just say copy a surface object at the given coordinates to our display. So to do this, I type in the name of the display. Our display is display surface, and then I'll call the .blit method. And now I have to give the surface. My first surface is going to be the dragon left image and its coordinates, which we've specified and positioned with our dragon left rect. And let's do the right dragon now. So I'll say display surface.blit dragon right image. And where do we want to put it? Well, we want to put it at the coordinates that we positioned with our dragon right rect. All right, let's run this. And there we see it. Now we see like our two dragons right there at the top of the screen. Perfect. Hey, as a review, I want to put a nice white line, I think, underneath them. So I'm going to just draw a quick line here. I'll do pygame.draw.line, and we're going to draw this to the display surface. The color, I didn't define any color, so that's fine. I'll just use a tuple right here. My starting point will be 0, 75. And my ending point will be window width 75. And let's make a thickness of, I don't know, 4. So that should draw a line underneath that. So if I run this now, there we have it. Okay, so awesome. This sort of looks like it could be maybe the beginning of like a HUD, right? Or like a heads-up display. So maybe like right up here I can have the score and like player live, some statistics for a game, and then we're playing the game down here, maybe for like some kind of neat arcade game. Awesome. So now that we know how to load images, get the rect of the image, position the rect of the image, and then blit the image to the display, I think this is a great place to stop. I'll see you in our next video. Hello and welcome back. In this video, we'll learn how to add some text to our display that we can later use to show off things like a player's score or the amount of lives that they have. So I'm going to open up a new file, new file. We'll save this as for blitting text.py. And we're going to start off with our normal things. So I'm going to import Pygame. I'll initialize Pygame by calling pygame.init. I'll create a display surface, and so we'll specify here our window width. I'll make it 600. We'll specify a window height. I'll make it 300. We'll grab a display surface by calling pygame.display.setMode and passing in as a tuple our window width and our window height. And lastly, I'll set a caption here, so I'll call pygame.display.setCaption, and I'll say blitting images. Okay, and then of course we need a game loop, right? So we'll say the main game loop. And we'll start by just defining a Boolean variable here, running is equal to true. And we'll say while running, what are we going to do? Well, we just want to check to see if the user wants to quit. So I'm going to say for event in pygame.event.get. So I'm going to get all of the events that have happened on this iteration of the loop, and we're going to check their type. So if the event .type, if its type is equal to pygame.quit. If it's a quit event, then we're going to set running equal to false. And once that breaks out of the loop, we'll say end the game. And we'll call pygame.quit. Okay, good. So, we should be getting really familiar with this. Okay, now I'm going to define some colors that we're going to use in this program. So I'm going to define my colors outside of my game loop. So I'll come up here and I'll say define colors. All right, so I'm going to do a green color, which is going to be 0, 255, 0. I'm going to have a dark green. We'll do a dark green, which is going to be 10, 50, 10, 50, and 10. And then I'll do black, which is just going to be 0, 0, 0. Okay, perfect. Now, let's talk about displaying text. In order to display text, we first have to declare what font we are going to use. And so we have two options in Pygame. We can use default system fonts on our machine, or we can bring in our own font files. So, you might not know what fonts are available to you on your machine. So to see the system fonts, we can call pygame.font.getFonts. And this will return a list of all available fonts. So let's do this. We'll say see all available system fonts. So I'm going to store this in a variable fonts, and we call pygame.font.getFonts. Right, because this is going to return a list of all the available fonts, and so now we'll store them in here. And so now let's loop through this list. So we'll say for font in fonts, let's print out the individual font. So let's just run this now, and let's see what type of fonts are available to us. Whoa. Okay, so let me close this, and you can see there's quite a bit of system fonts that are available for us to use. All right, so we're going to use this, but we're also going to want to maybe use our own font files. So I have a font asset, a tech graffiti, that accompanies this video that you can download. But let me just show you where I got it really quick. So if I come over here to font space that I showed you before, and we click on the commercial free, here is attack graffiti right up at the top. And so you can download that right here. And then when you download it, just grab the TTF file and make sure the TTF file, the true type font file, is in the same directory as our script. So again, we're putting all of our assets in that same script. Okay, so now we can use that system font, and we'll load this up. Okay, so let's see. Now I've got let's load these fonts actually. Okay, so I'm going to come here. We'll go right here, and we'll say load fonts. We'll say define fonts. Why don't we'll keep the same language. Define fonts. So I'm going to define my system font. And to do this, I call pygame.font.sysFont, so system font. And inside of here, I have to pass the font. So I'll pick Calibri. That was one of our system fonts. And then you have to give a font size. So I'll give a font size of, say, 64 here. All right, and then let's load in the custom font that I have in my directory here, that attack graffiti. So I'll call it custom font is equal to pygame.font. And now instead of sysfont, we just simply type font. And now I'll pass in the name attack graffiti. And I have to give the file extension. So this is a TTF or true type font file. And I'll specify its size. So I'll make it 32. All right, great. So now we have these fonts loaded. I can actually create some text with them. Adding text is similar in Pygame to adding images. So if you think back, right, when we added images, we first had to load the image onto a Pygame surface. Then we got a rect of that surface, and we positioned the rect. Then we lastly blitted the image surface to the screen at the coordinates of the rect that we created. And adding text is almost exactly the same. Instead of loading an image, however, what we have to do is render the text that we want to display. So rendering creates a new surface with the specified text that we give it rendered right onto it. This text can only be a single line, though. So like new line characters are not going to be rendered. So often what we have to do if we want like multiple lines, we have to render multiple surfaces. Once we render the text, the parallels to adding an image are almost the same. So let's create some text now. We've got our fonts defined, so we'll come here, we'll say define text. So I'll create something called system text here. So this is going to be my rendered text surface. So the way we render our text is you first have to pick the font. So I'm going to start with my system font. So I'll say system underscore font dot render. So we'll call the render method. And now in here, we have to pass in what text we want to render. So I'll say I want a text, the text to say dragons rule. And then we're going to pass in a Boolean true. This is for anti-aliasing. And then we pass in the color of the text and the background color. So I'm going to pass in a color of green, and I'll pass in a background color of dark green that we previously defined. You don't have to enter in this background color. If you don't, it'll just take the background of whatever surface you have. All right, so now this right here is going to render the text onto a surface object, and that surface is going to be called system text. So what we need to then do is get a rect of this surface. So I'll say system text dot underscore rect is equal to system text dot get rect. So this is good. I now have a surface and I now have a rect, and I can use the rect to position the surface. So let's position this. So we'll say system text rect, and I'll position it via the center. All right, so I'll put it right in the center, and I want this to be right in the middle of my window, and then sort of down a bit. So on the x coordinate, I can do this by calling window width divided by 2. Again, we're going to use floor division, so we get integers, and then I'll position it at 150. Actually, let's position it at window height divided by 2. We'll put it right in the center. Okay, so there we have it. Let's do something similar for our custom font. So let's make another text surface. So we'll say custom text is equal to, now we're going to render our custom font. So custom font.render, and inside of here we'll say move the dragon soon. All right, so we're going to be moving that dragon soon. Again, we'll pass true for anti-aliasing, and this time I'm just going to do a green color. We're not going to put a background color, so the background will just be whatever color the background of our display surface is. So I have this custom text surface. I need to get a rect for it. So I'll say custom text rect is equal to custom text.getRect. So we're getting the rect of the surface. And this is really great because now I have a surface, I have a rect. I'm going to use the rect to position the surface. So I'll say custom text rect.center. I'm going to center it window width divided by 2, so right in the center horizontally, and then we're just going to put it a little bit below the other text. So I'll say window height divided by 2, and I want to go below it, so I have to add in the y direction. So I'm going to add, I don't know, I'll add 100. Maybe that'll work. We'll see if this works. Okay, so this is really good. We have our font set up, but of course you know that if I run this right now, nothing is going to happen. At least it shouldn't. I'd be very surprised if it does. And there you go, right? Nothing's there because we haven't yet blitted these, text surfaces to our display surface. So we've got to do that right now. So we'll come down here and we'll say blit or copy the text surfaces to the display surface. All right, so let's wrap that up. So how do we blit to a display? Well, we call the display's name, so display surface.blit. Then we pass the surface that we want to blit. Well, ours is the system text, and we have to give the position of it. Well, our position is going to be governed by the rect that we've already positioned. So we'll say system text rect. And we'll do the same thing for our custom text. So display surface.blit. Custom text is the surface, and then we'll say custom text rect is the position that we want it. And then lastly, if we want to actually see these changes, we have to update our display. So we'll come over here and we'll say update the display by calling pygame.display.update. Okay, so if we run this now, we should see our text nicely appear exactly where we positioned it. And there we have it. So that's kind of cool, right? So it says Dragon's Rule, and you can see that nice background color right in the center of our game window. And then we have below that, Move the Dragon Soon, in our custom font. Awesome. So, a really nice video here. Whether we're blitting images or whether we're blitting text, the idea is the same. You have to create a surface, whether you load an image or you render text. Once you have that surface, we're going to get a rect, and we're going to use that rect to position the surface. Once it's positioned, we then have to blit the image surface or the text surface to the screen. I think this is a great place to stop. I look forward to seeing you in our next video. Hello and welcome back. so far we've seen how to create our display surface, which is essentially our game window. We've seen how to draw geometric figures onto this display, how to blit images, and how to blit text. Our programs have been pretty static so far, and that's okay. We'll add movement soon. But before we do, let's add an often underlooked aspect of game design: sound and music. Sound and music can add so much to a game. A game lacking in sound effects or, good background music is rarely an enjoyable experience in my opinion. Luckily for us, Pygame has a pretty robust and easy to use mixer that we can use to control all of our audio needs. So I'm going to make a new file here, file, new file. I'll save it. I'll call it 5, and we'll call this adding sounds.py. And just like we've been doing, we're going to start with the basics. So I guess I could just copy and paste this from our previous ones over, but I really do feel it's important for us to go through it each time to get some muscle memory and really understand what we're doing. If you disagree, I'm sorry. Feel free to just copy and paste it over and skip ahead in the video, but I'm going to go through and do this. So we'll start by importing Pygame, and then we'll initialize Pygame by calling pygame.init, and we'll create a display surface. All right, so our display surface, we're going to give a window width. I don't know, I'll set it to 600. We'll give a window height. I'll set it to 300, and we'll grab our display surface now. So display surface, and you can call that whatever you want. I like display surface, but if you want to call it game window, go ahead and do that. Pygame.display.set mode, and in here we'll give the tuple of our window width and window height. And lastly, we'll set a caption. So I'll say pygame.display.set caption, and we'll say adding sounds. Oh, if I can spell it right, adding sounds. There we go. All right, now we need our game loop. So we'll say the main game loop, and inside of here, or down here, we're going to put a Boolean running, set it equal to true, and we'll use this to control our while loop. So while running, and we're going to loop through just to see if the user wants to quit. So we're going to loop through all events that have happened in the iteration of the loop. So for event in pygame.event.get, and so remember, these could be like mouse clicks, mouse movement, keyboard clicks, etc. Right now we only care about one type of event, and that's the quit event. So we'll say if event.type is equal to pygame.quit, then what are we going to do? Well, we're going to turn running to false. Capitals, right? Capitals. Okay, and then down here, we'll just break out of our loop. We'll say end the game by calling pygame.quit. Okay, there we go. So there's like our basic setup. Sorry, so if I run this, we should just get our window. All right, there's our window. Looks great, and I can close out. Awesome. So now let's go get some sound assets. So I'll be working with two sounds, sound 1 and sound 2, as well as a music file. So these sound assets are accompanying the video, so you can download them right here. But let me also show you where I got them really quick. So if I come over here, I'm going to go to the Leshy sound effects maker from Leshy Labs, and I just picked some random ones, right? So you can, pick different sound effects. You can alter the waveform, the frequencies, the durations of things. There's also some really nice example sounds down here. So if you need an explosion, you can just pick one of these. If you need like a jump sound, there you go, a bounce sound. There's also songs here, which is kind of cool. So like, I'm actually going to use that one, I think, or a variation of that later on. But you can actually, with the song mode right here, you can actually add notes to it, which is kind of cool. And then you can just, of course, save your sound files. So I've already done this for us. The sound effects were from Leshy Labs. The music file that we're going to use for our background music, I actually wrote using FL Studio, a program that I have right here. Music's sort of a hobby of mine, so I might make some background tracks. So you won't find it online, but feel free to use the audio that I give you any way you want. So if you want to use it in any of your future games, go ahead. Also, if you don't like the audio that I'm using, the sounds that I'm using, feel free to, pick your own. All you want to do, though, is make sure that when you download them, they are in my Pygame course, basic Pygame. Make sure that your sound effects are in the same folder as the Python script that you're currently running. Okay. So now that we have our assets, let's load up these sounds. So in order to do that, I'm going to come down here outside of my game loop. I'm going to say define sounds. So I'm just going to say load sound effects because we're going to do just the sound effects first. So we're going to use Pygame's mixer to do this. And so I'll call my first sound sound1, and I'm going to set it equal to pygame.mixer.sound. And now I just have to pass in the path to the sound. Well, since it's in our directory, I just have to type in sound1 and then give the file extension. So this is a WAV file. And then we'll also load in sound2. I'll call it sound2 by calling pygame.mixer.sound. And so we're going to load in sound2. That wave. The background music, you actually do something different. So we're going to talk about that later. So now I have these two sound effects loaded. So maybe I want to play the sound effects. So I'll say play the sound effects. So these are sound objects, and the sound objects have an associated play method. So I can call sound1.play. And so if I run this right now, I should hear that sound effect. Hey, and there it is, okay? And so let's play the second one. So I'll say sound2.play as well. And what happened? This is kind of interesting. It seems like sound1 maybe didn't play. What happened is we didn't give any amount of time in between this call and this call. I mean, the speed of our computers, those are happening so quickly. We actually have to specify, hey, computer, wait for a little bit. And so what we can do is in between these calls, we can actually call pygame.time.delay, and then inside of here we can pass an amount of time to delay in milliseconds. So let's wait 2,000 milliseconds, or 2 seconds after we play our first sound, to then play our second sound. All right, so this call will hit and we'll wait as this sound is playing, and then we'll play our second sound. There's our first, and there's our second. So that it worked pretty good. And so just because we're going to be continuing to play some sound effects, I'm going to actually make another call to delay here, and we'll wait another 2,000 milliseconds. Now, I actually thought that that second sound was a little bit too loud, in my opinion. So we can actually change the volume of a sound effect. And so in order to do that, I'm going to call my sound2, and I'm going to call the set volume method. Now inside of here, this takes a value 0 to 1. So the lower the value, the lower the sound. And I want to significantly lower the sound. So I'm going to pass in a value of 0.1. And so now if I call sound2.play, we should hear that a lot softer. So let's listen. Our first sound effect, our loud second, and our quieter second. So it did work, right? And so now, anytime I play this, in fact, that volume is going to be set. You don't have to call this every time you want to lower the volume, all right? Great. This is really great. But what about background music, right? Well, we can actually load a file into Pygame's audio mixer as music pretty simply. So let's do this right now. So we'll say load background music. And so here, all we have to do is just access our audio mixer. So that's pygame.mixer. And before we were using, right, what were we doing? We were doing pygame.mixer.sound for sound effects. We're going to do .music here. And it's lowercase. And what do we want to do with this music? We want to load it. And so now I'll pass in the path, which I just called music.wave. So now the music is loaded into the mixer. So what can we do with the music? Well, we can play it, right? We can play it, we can stop it, we can do all that good stuff. So let's actually come over here and let's play and stop the music. So to play the music, we just get the mixer. So we'll call pygame.mixer, and then we'll call music.play because we want to play it. And now inside of here, we actually have to pass a couple of arguments. The first is how many times you want to loop through it. So if you just do 1, it'll only play it once. 2, it'll play it twice. 3. If you want an infinite loop, which is what we tend to want to use for background music, you type in -1. And then you have to pick the starting time. So I want it to start right at the beginning, so I'll do 0.0. All right, and so that's going to just continually play the music forever and ever and ever. I think. Let's just check. Sound effects. Okay, there's that loud one. There's our quiet one. And there's our background music. And it's just looping over and over again. The clip is actually only like 5 seconds long. And so this loop is just going to keep going forever and ever until we close out of the game. So we also can stop music. So a lot of times, right, like if a player, if it's like a game over, you might want to stop the music. So let's play this for a little while. So I'll call .time.delay, and I'll do 5,000. Okay, so I'll wait like 5 seconds. The music will play for 5 seconds, and then I want to stop the mixer. So I'll call mixer.music.stop. All right, and so now let's check this out. So now we should see that the music stops after about 5 seconds. So there's our first sound effect, our second sound effect, our lowered volume sound effect, and we go right into our background music, and it should stop. And there it is. It stops. Perfect. And so, one of the things I will say is, while this background music is playing, you most certainly can, play sound effects too over the background music, which is really nice. In fact, why don't we do that? So I'll say pygame.time.delay, and we'll wait 1,000 milliseconds, and then I'll play sound 2 again. So I'll do sound 2.play, and you'll hear that sound effect play over the background music. Okay. And there it was. So you heard that right there, and then we can stop our audio when it stops. Okay, great. We now have some basic functionality with sound effects and background music, which will add a lot to our game experience once we start making our games. Now that we know how to add some of the different types of assets, like text, images, and sounds, we will begin to see how we can make our games more dynamic by interacting with our assets, such as moving an image by pressing a key on the keyboard. And I'll begin showing you that in our next video, so I can't wait to see you then. Okay, get ready. What you have probably been waiting for is about to happen. In this video, you are going to be able to press a button on your keyboard and move an object on the screen. Hey, that's like the basis of what a game is. This is the beginning of actual gameplay, so I'm really excited about this. And it's huge because this is a course, after all, about making games in Python. So before we get ahead of ourselves, though, let's create a new file. So I'll save this in the same directory. I'll call it 6, and this is going to be called discrete keyboard movement. .py. We'll give it that extension. And like always, let's do our basics. So I'll import Pygame. We'll initialize Pygame by calling pygame.init. Let's create our display surface by specifying a window width. We'll make it 600, and a window height. We'll make it 300. We'll grab our display surface. I'll call it display underscore surface, and I'm going to set it equal to pygame.display.set mode, passing in as a tuple our window width and our window height. And then let's set a caption. So pygame.display.set caption, and this will read discrete. Oh, not all capitals. I'm not yelling it. I am excited, but not that excited. Discrete movement. Okay, perfect. And now we need a game loop, of course. So we'll say the main game loop. We'll use a Boolean running, setting it equal to true. And we'll say, while running, while this variable is true, let's loop through. And so what are we looking for? We're just looking to see if the user wants to quit right now. So we're going to grab our events in the event queue by typing pygame.event.get. That's going to give us a list, and we'll loop through it. And we're going to see if the event that we're currently looped on, if its type, so event.type is equal to pygame.quit. If it's a quit event, then we're going to set our Boolean running to false. And lastly, all the way down here, we'll just say end the game by calling pygame.quit. Oh, not .quit. All right. So that setup looks really good. Okay. So now the two things that we're going to do right off the bat here. We eventually, the scope of this is movement, right? So we're going to have an image, and we're going to move the image on the screen anytime we press a keyboard. So the first thing I'm going to do is I'm going to define a constant variable. So I'll say here set game values, and I'm going to call this constant variable velocity, and I'm going to set it equal to 10. All right, and so I'm using a constant variable here, and hopefully at the end I'll show you why it's really important. And next we're going to load in our image of our dragon. So we'll say load in images. Okay, so if you recall, the first thing that we have to do when we load an image is we have to create a surface by loading the image. So I'll call this dragon image is equal to pygame.image.load, and I'll pass in the path, and we'll use dragon right here. So I'll say dragon underscore right.png. So there's the surface But now I need to get a rect of this surface, right? A rectangle that kind of covers the surface. So I'll call this dragon rect. And we can do that by getting our surface, dragon image, and we'll call .get rect on that. So now I have a rectangle, and I can use that rectangle to position my dragon. So I'll start by saying dragon rect. Let's do dot center x. So I'm going to center it horizontally. I'll center it at window width over 2. And let's do dragon underscore rect dot bottom. The bottom of it, I'm going to put right at the bottom of the window. So I'll do window height. So it'll put it right in the center of the window horizontally all the way at the bottom. And so you can see I kind of had to do the X and the Y separately here for the rect. Okay, perfect. So now we have this loaded. Let's actually blit this image to the screen now. So inside of my game loop here, I'm going to blit or copy the image, copy, we'll say assets to the screen. And so to do this, I type in my display surface dot blit, and I have to pass in the surface that I want to blit. Well, I want to pass in my dragon image, and I have to pass in the coordinates, which are given by our dragon rect that we've positioned. Now, we're not going to see those changes right now, right? And let's just run this to verify. Even though I'm blitting it to the screen, I'm not seeing any of the changes because we haven't yet updated the display. So the last thing we need to do inside of our game loop is update our display. Update the display by calling pygame.display.update. All right, and so now we should see that dragon positioned exactly where we want it, and there it is, right? Midpoint, window width over 2, and the bottom is at window height. Awesome. Very, very good. Okay, so now let's get into movement. So each iteration of our game loop, right? This game loop is constantly running. We want to check to see if the user has pressed an arrow key. If they did, then they want to move the dragon. And so we're going to move the dragon. And what do I mean by moving the dragon? We're going to change the dragon rect X coordinate and Y coordinate, right? We're going to change the X and Y coordinate. Now, this isn't too bad, right? Pressing a key, if you remember, we saw that earlier, pressing a key is an event in Pygame. And so, I don't know, right here, let's just print, I'll print event for right now. And so if I run this, okay. Is it not doing it? Why is it not doing it? Let me see, what did I do wrong here? For event in Pygame, print event. It should be printing our events. Why is it not doing it like it did before? Let's try it again. Oh, it was. I was all the way at the top of my oops, I was all the way at the top of my window. Okay. So, right, if I like press the right key, you can see it's a key down event. All right? Here I press the left key. It's key down, key down. And if you notice, right, the keys all have specific where did it go? Let me close this out. The keys all have like specific key codes, right? So here's a key code. I don't even know what key that was. Was it the right key or the left key? And here's the other one, probably the opposite of that. So we have these events keyed down that we can look for, okay? Just like we looked for our quit event right here, we can now look for key down events. So let's do that. So inside of this loop in which we've just gotten all of the current events of the the iteration of our while loop, let's check for discrete movement. So we're going to say if event.type is equal to pygame.keyDown. So if it's a key down event, meaning you pressed a key, we want to do some stuff. We want to move the dragon, right? Well, we've got to figure out first what key was pressed. And so I told you that, right, every key has its own key code, like a number that's ungodly hard to remember. There's an easier way to do it. So for this event type, right, if it's a key down, what we're going to say is we're going to do if the given event dot key. So the key attribute is going to give us the key that was pressed. And instead of entering in like that long number, what we can do is just type in pygame dot k, capital K underscore capital left. So that's going to be like the left key right here. So if that is the case, right, so if an event's happened in our queue on this loop, if the type of the event was a key down, meaning the user pressed a key, and if the key of that key down event was the left key, what do we want to do? Well, we want to move the dragon left. So how do we do that? Well, I said moving the dragon means we have to change the X and Y coordinates of our dragon rect. So we'll say dragon rect, And here I'm going to change the x coordinate. And to move it left, I'm going to subtract the velocity, right? Because we set this velocity right here as 10. So I'm going to do minus equals velocity. So let's run this right now and let's see if this works. There's my dragon. And it's moving to the left. Although it's extremely terrible looking, right? Because what's happening? Well, it moved to the left, it moved to the left, it moved to the left, but all of the other dragons are like still there. So right here you can see we're sort of copying our dragon to the screen. Before we do that, what we need to do is we sort of have to like wipe our screen or clear our screen. So I'll say here, fill the display surface to cover old images. And so we'll say display surface dot fill, and we'll just fill it with whatever our current background color is. We're using black, so I'll just do 0, 0, 0. And I didn't define the color. That's fine. It doesn't matter. So now, right, every iteration of the loop, we're going to start by just making it a black surface, and then we're going to blit the new dragon at its new location. This should look a lot better. And there we have it. Every key press, the dragon is moving to the left. Awesome. Let's add in our other directions. So let's come over here. If event.key, if our key on the key down is pygame.k right. So now we press the right key. Well, we still want to change our dragon rect its x coordinate, but now instead of subtracting our velocity, we're going to add our velocity. All right, so that's left and right. Let's do up and down. So if event.key is equal to pygame.k underscore up, our up key. Now we're not going to change the x position of the rect, we'll change the y position of the rect. And remember, to move up, you are actually decreasing your y coordinate moving up. So we have to subtract velocity. And we'll do something similar here for the down key, event.key. So if we press the key and that key is equal to pygame.k down, then we're going to change the y coordinate of the dragon rect. And here we have to add to move down. So we'll say velocity. All right, so I think our movement here is going to work pretty nicely. Let's run this and test. All right, so I'm moving left, I'm moving right, I'm moving up, I'm moving down, I'm moving up and to the right, I'm moving down and to the left. So that's kind of nice. I can move it. And it's discrete. Why is it discrete? Well, if I press the right key and I hold it, it only moved once, right? I have to press it each time to move it. We'll talk about continuous movement in an upcoming video. One of the last things I want to just talk about here is you can kind of see, right? Velocity, 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 all of these constant variables. Right now, the velocity is set to 10. Let's say I want to do a bigger jump. I don't know, 30. I only have to change the constant variable value here, and it changes all of these, right? If I actually typed 10 in, I'd have to change that over and over and over again. And so using these constant variables is a nice way that we can sort of test and modify the gameplay of the game in a quick and easy manner. So I really like that. Awesome. I think this is a really great place to stop. We've added some discrete movement. We've talked about a new type of event in Pygame, the key down. And now we're starting to make some dynamic games, which are a lot more fun, in my opinion. So this is a great place to stop. I will see you in our next video. One way to interact with our games is a keyboard. But another way is with a mouse. In this video, we'll learn how to use mouse events in a few different ways. So let's open up a new file, new file, and I'm going to save it here in the same directory I've been working on, and I will call this, it's our 7th script here, so 7 mouse movement.py. All right, and let's go through the basics, right? So we'll import Pygame, we'll initialize Pygame by calling pygame.init. We'll create a display surface. We'll specify our window width, window underscore width as, let's make it, yeah, we'll keep it 600, window underscore height as 300. We'll grab our display surface. I'll call it display underscore surface by typing pygame.display.setMode. And we'll pass in as a tuple our window width and window height. And then we'll set the caption. So pygame.display.set caption, and here we'll say mouse movement. All right, and then we need a game loop, right? So we'll say the main game loop. We'll use a Boolean running, set it equal to true, and we'll use this to control our while loop. So while running, we're going to first just check to see if the user wants to quit. So we have to look at all events that have happened in the event queue. So for event in pygame.event.get. All right, and we're going to check if that event type, so if event type is equal to pygame.quit, then we want to quit. So we'll set running, our Boolean, keeping track of this while loop, to false. And then lastly here, we'll just end the game by calling pygame.quit. Okay, so again, really good setup here. Now, what do we need? Let's load in some assets. We're going to need our dragon image that we want to move with our mouse. So we'll say load images, and so I'll call this dragon image, dragon underscore image. Here's our surface, so pygame.image.load, and we'll say dragon underscore right.png. So we've got the surface. Now I want to get a rect for this surface so that we can position it where we want it. So we'll say dragon rect is equal to, we just called the surface that we created, dragon image, and we call its get rect method. Now that we have that rect, let's position it. So I'll say dragon rect dot, I don't know, let's use dot top left, and I'll position it 25 pixels from the edge of the, top left equals, there we go, 25 pixels from the edge of the upper left-hand corner. All right, great. So now instead of moving the dragon with our keyboard, we're going to move the dragon with our mouse. So we'll start by moving the dragon to wherever we click on the window. So like if I click over here, the dragon should just shoot over. Clicking or pressing down on a mouse button is an event type in Pygame known as mouse button down. So let's actually look at that. So inside of my game loop here, for event, I'm going to print the event. And so we'll run this really quick. So you can see, oh, I got to get down all the way to the bottom of here. There we go. So you can see I just pressed my button, mouse button down and mouse button up. Okay. So we want to check for those type of events. Also, if you look at like our mouse button, where is it? Mouse button down. Where's one? Okay, mouse button down, we have a position, right? And this is the X coordinate where the click happened and the Y coordinate where the click happened. And then we also have a button value, which is kind of nice. Button value is 1. That, for my mouse, that's my left mouse button, okay? So let's use this to try to move our dragon. I think I'm getting maybe ahead of myself though, right? Because before I move my dragon, it's not even loaded on the screen yet. I got to blit it to the screen. So we'll say, let's say fill the display. So we'll call display surface.fill so we don't get that like really glitchy effect here. And that color's got to be a tuple. So you got to make sure that there's parentheses inside your parentheses. I always forget to do that. Then we'll blit surfaces, or we'll just say blit assets. And so my display surface dot blit, what do I want to blit? My dragon image at its rect, okay, dot dragon rect, and then we'll update the display. Update the display by calling pygame dot display dot update. Okay, now we're ready to maybe move the mouse based on clicks. So inside of here, inside of this loop where we're getting all of our events, I'm going to say we'll say based on mouse clicks. Okay, so we're going to try to look to see what event type just happened. So if event.type is equal to pygame.mouse button down. We saw it was called mouse button down. What do we want to have happen? Well, let's print the event here, right? Let's print the event. So I'm going to get rid of this call. And let's just print the event. Let's just make sure that that's working. All right, so it shouldn't print anything until I click in the screen, and there we go. So right, if I click right up here in the upper left-hand corner, it's like, you know, position is like 2, 2. If I click in the 25, 25 is where I think I set that. So it's pretty close, right? Up here's the right corner. So we're getting like the XY coordinates of our click. And so the position here is a tuple, and this is the X coordinate is at index 0, the Y coordinate is at index 1. And so we can actually use those here in this call. So let's create a variable mouse X, and we're going to set it to the event. and its position attribute at index 0. That was the x coordinate. And let's create a variable called mouse y, and we'll set it to event.position, the position attribute, but the first index, which was the y coordinate. And so now I have these x and y coordinates, and I'm going to use the x and y coordinates of our mouse clicked to change the dragon's rect. So I'll say dragon rect.x is equal to mouse x, and I'll say dragon rect.y is equal to mouse y. And that should move our dragon for us. So wherever we click, our dragon should hopefully follow. So let's look. Hey, and look at that. There it is. Now, one of the things I don't like is if you notice, I click, like, watch where I click. I clicked here, and the mouse is moving, the dragon is moving, so the top left corner of the dragon is where I clicked. I don't like that at all. Let's center it. So here, instead of dragonrect.x, I'll do dragonrect.centerx and dragonrect.centery. And that will center it right on our mouse click. It should. Let's see. Yeah, that's much better. So now I can click and move the dragon. Awesome, awesome, awesome. Let me close out of some of these other windows that I have. Okay, great. So now, what if we want the dragon to sort of follow, move on its own wherever my mouse is on the screen, right? So as I'm moving the mouse, the dragon is moving again. So this is just another event. This type of event is known as mouse motion, right? So it's the mouse motion event, and we've seen this. So let's check this out here. So let's add another event. So we'll say if event.type is equal to pygame.mouse motion. So that means, like, if we move the mouse, we'll again print the event, and let's just print the event and make sure that it's giving us the same thing we expect. Right, so as I print the event, okay, good. You can see I have, again, a position attribute, so with x and y coordinates, and we're going to use those x and y coordinates to then change the dragon's rect. All right, so we're actually, I can actually just copy and paste this exact code. Right, so we're going to define mouse x as our current event's position at index 0, that's the x coordinate, y is position 1, and then we'll position our mouse. So let's see if this works. And it does. I'm like moving the mouse. It's following my mouse wherever it goes, which is kind of cool. So, but it does sort of like diminish this mouse click, right? So let's try one last thing. Let's make it so that the dragon only moves, and I'll put this here as a comment. We'll say drag the object when the mouse button is clicked. So what I want to have happen is I want to be able to click anywhere on the screen, and the dragon will move. But then if I click and hold, then I want the dragon to follow me. And so what we can use here is, if we run this again, let's look at our mouse motion. You can see it right now, see the buttons attribute, it's 0, 0, and 0. I'm going to hold my left button. And so now when I'm holding and moving, you can see buttons, that first index became 1. So that indicates that the left button was pressed. I'm going to press the right button now. Okay, that third value became 1. So that indicates that the right button is pressed. That second value, I think, is my scroll wheel. If I press my scroll wheel, yeah, that's pressed. Okay, so we can actually use the buttons attribute here to determine if someone's holding a button, and like we can click and drag sort of thing. So right here, we just need like a joint conditional statement. So if there's mouse motion, and, right, we're going to use and because we want both of these things to be true. If the event's button attribute, so buttons, and which one was I concerned with? I'm going to do left button, which was index 0, that first element, if that's equal to 1. So this means the user has pressed and is holding the left mouse button, and they're moving the mouse, then we'll drag that dragon. So let's see if this works now. Okay, so right now I'm moving the mouse. The dragon is not following, so that's good. I can click here. The dragon moves, dragon moves, dragon moves, dragon moves. So now I'm going to click, and I'm holding that button down, and now I can drag him all over the screen. So this is working perfectly. I'm really kind of happy and excited with how this came out. I really like it. I think this is a good place to stop for this video. Here we've talked a little bit about some new events, mouse button down, mouse motion, and how we can look at the event to sort of trigger some events that we want to happen in the game. I will see you in our next video. Hello and welcome back. We've seen how to use a keyboard to move an image in a set quantity or discretely, and we've seen how to move an image with our mouse. In this video, we're going to see how to do what most games tend to allow you to do, and that's move continuously with a keyboard. So when you press and hold a key, your character continues to move. This is a little bit more involved, but nothing we can't handle. So let's start. I'm going to open up a new file, and I'll save this. This is our 8th script here in this basic Pygame folder. I'll call this continuous keyboard movement.py. Okay, perfect. And let's go through our basics. So I'm going to import Pygame, initialize Pygame by calling pygame.init. I like to comment my code, especially for these like tutorial videos, right? I think it's helpful because you might reference these later on, this code later on, and so it's helpful to have everything commented nicely. We'll make a window width of 600, we'll make a window height of 300. We'll create a display surface that we'll be able to reference later. So display surface is equal to pygame.display.setMode, and we'll pass in as a tuple our window width and our window height. And then let's set our caption. So pygame.display.setCaption, and we'll say continuous movement. Now we need a game loop, so we'll say the main game loop here, running is equal to true, and we'll say while running, what do we want to do? Well, we want to just look to see if the user wants to quit. So we'll say for event in pygame.event.get. We'll get all of the events in this iteration of the loop, and we're going to see if the given event's type is equal to pygame.quit. If it's a quit event, then we're going to set our Boolean running to false. Awesome. And then the last thing we'll do is we'll end the game by calling pygame.quit. And that just uninitializes anything that we initialized up here. Okay, perfect. So now what I'm going to do is let's set some constant variables, right? We're going to move. So like if you remember in our discrete movement, I think we set a constant variable for velocity. We're going to do something similar here. So we'll say set game values. We'll do this above our game loop, and I'll call this velocity, and I'll set it equal to 5 for right now. And let's load in an image. So we'll say load images. And so we're going to load in our dragon. So we'll say dragon image is equal to pygame image image.load, and then we'll load in the file name dragonRect.png. So that gives us our surface. Let's grab a rect for this. So we'll say dragon rect is equal to the dragon image surface dot get rect. Right? Surfaces have this get rect method that we can call, which gives us the rectangle surrounding the surface. And once we have that rectangle, well, then we can position it. So we'll say dragon rect. And I'll use the center attribute, so we'll center it, and we'll say window width over 2, window height over 2. Okay, I'm pretty happy so far. Perfect. So now inside of our game loop, let's actually update our display. So we'll fill the display so we don't get that weird, like, where the old images were still on the display. So we'll say display surface.fill, and we'll use black here just to keep it easy. And then we will, what do we got to do next? We got to blit our dragon to the screen. So we'll blit assets by calling display surface.blit. What do we want to blit? Well, the surface is the dragon image and the location is the dragon rect. And then we'll update the display by calling pygame.display.update. Okay, so if we run this now, we should see our dragon appear right in the center of the screen. Perfect, there it is. So now what we want to do is we want to move the dragon as long as we are holding down a given key, right? So if I like press the right key and hold it, the dragon should continuously move to the right. This is very different than what we previously did when we only moved the dragon when a key was pressed. See, like pressing a key is a key event in Pygame. It's the key down event. But a key being held down is not an event in Pygame. luckily for us, we can get a list of all of the keys that are currently being held down pretty easily. And so let's see how to do that. So I'm going to do this inside of my game loop, right? Because we want to check every iteration of the game loop. We want to check to see if keys are being held. So I'm going to come here, but I'm going to go outside of our for loop where we're looping through the events, because we just said holding a key isn't an event. Pressing a key and releasing a key is an event. So here we'll say get a list of all keys currently being held. And so I'm going to call this keys. And we can call this by typing in pygame.key.get_pressed. So this is going to give us all of the keys that are currently being pressed down. And maybe I'll change this from held to pressed down. There we go. So the language is kind of the same. And so now let's just print those keys. So if I run this, look at that. We're just printing a ton of zeros, right? And that should hopefully make sense. All those zeros are being printed because I'm not pressing any keys. But as soon as I start to press keys, I don't know. Can you see? I think I just saw like a 1 appear. I'm pressing and holding some keys, and you can see that there are some 1s that are popping up. So where the 1s pop up here in this like endless sea of zeros, I don't even know if I can scroll to like get a 1. Yeah, I can't. But I'm sure you saw them. Where the 1s pop up at that specific index here, it corresponds to a given key being held down, right? So, like, let's say the left key, right? If this index right here represents the left key, well, if it's a 0, it's not being held. It's false. And if it's a 1, then it is being held. So that's true. So we can actually use this kind of to move our dragon. So this is going to work, I think, pretty nicely. So here we'll then say move the dragon continuously. Okay, so we're going to say if keys, so there's our list, right? And so we're going to check the item, we're looking for the item pygame.k_left. I have no idea what the index is of this, but we can use, this reference pygame.k_left like we did before. So if it's not being pressed, this is going to be 0, and so that's going to be a false statement. If it is being pressed, it's 1, and 1 is going to be a true statement. Then what do we want to do? Well, we want to move our dragon to the left. So how do we move a dragon? How do we move our image? We move its rect. So we'll call the rect, and we want to move the x coordinate. And to move it left, we'll subtract our velocity. So let's check this to see if this is going to work, if this is going to continuously move our dragon. Well, and so there it went. And it went right off the screen. So, I mean, I guess it worked. We'll talk about why it only worked partially in a moment, but let's fill in the rest of this the keyboard here, these keyboard controls. So we'll now say if keys, let's do the right key, pygame.k_right. Then we're going to move the dragon rect x coordinate. Oops, where'd that go? I want dragon rect.x by adding our velocity. Okay, so that looks pretty good. Except, what did I do? What's wrong here? Dragon rect.x. I don't think anything's wrong. Did I make a mistake? Maybe it'll go away. If, because that's what happens with most mistakes, right? That happen. They just tend to go away on their own. Pygame.key_up. We'll do up next. So then here we're going to move the dragon rect's y position, .y, and we'll minus equal our velocity to move up. And it looks like it is not going away. Let's see. Oh, there it is. I forgot my square bracket right there. So a little bit of debugging. Okay, perfect. Hopefully you didn't make that mistake. So remember, right, to move up, we have to decrease the y coordinate of our rect, so we're subtracting our velocity. And lastly, if keys, pygame.key_down. So if that's a 1 for the down key, then we're going to move down. So dragon rect.y plus equals velocity. Okay, good. So now we should be able to kind of move in any direction. So let's run this. All right, and I can, but what's happening is the dragon is moving way too fast. I mean, I set the velocity to 5, and it's like going all over the place. So like, why is that? Well, what happens is the dragon's moving really fast, and that's because we're moving our dragon right here inside of a while loop. So every iteration of this while loop that runs, we're going to move the dragon. Like if I'm holding the left key down, every iteration it's moving at 5 pixels to the left. And this while loop is running extremely fast. It's running as fast as, essentially as fast as like my computer can run it. And some computers may be faster than others. Some computers may be slower than others. So you can see that this poses a problem, right? What we need to do, we kind of have to do two things. We have to slow this while loop down, and we need to ensure that it's going to run at the same speed on every single computer. Luckily for us, we can accomplish this by using something known as a clock. So I'm going to go to the top of my code here. And right here, let's see, I'm going to go to the top of my code, and I am going to define a clock. And I'm going to define a new constant variable, FPS, or frames per second. So let's see how to do this. So I'm going to say set FPS and clock. So FPS, or frames per second, I'm going to set to 60, and I'm going to create a clock object by typing pygame.time.clock. Perfect. Now, a clock is a fantastic tool here. A clock ticks just like a regular clock, except we can control how fast the clock ticks, and this can be used to control the frame rate of the game. Essentially, how quickly each individual computer is going to run the game loop. With our clock created, we can now slow down our game by ticking the clock at the end of the game loop. So if I come down here at the end of my game loop, after I update my display, I'm going to tick the clock. And so to do that, I'm going to call my clock object. Oh, my clock, right? I called it clock. Did I call it clock up here? Yep, clock. So I'm going to call clock.tick. And then inside of here, I'm going to pass in my frames per second variable, in my case, 60. So what this is going to do, this will have my clock delay my game loop such that the game on any given machine will never run faster than however many frames per second I put in here. So it's going to like limit, slow my loop down to only run at 60 frames per second. So, and this should work on any machine. So the gameplay should be like uniform across all machines. So if I try this now, our movement should be much slower. And it is. There we go. So I'm continuously holding that in, and our dragon is moving. So let's see what happens really quickly here if I change my FPS to something lower. Like let's change our FPS to 10. So now if I run it, where'd my window go? It's up here on my second screen. Sorry, there we go. So now if I run it, my dragon's moving a lot slower, right? So, and that should make sense because now our loop is only going to run 10 times a second, whereas before our game loop was running 60 times a second. So lowering your frames per second essentially means it's going to run a slower gameplay, and upping it is going to be faster gameplay. So I don't know, depending on the style of our game, we'll change this. I'm going to keep this at 60 for right now. Awesome. So we've now seen how to do continuous movement based on if a key is being held down, and we introduced a really crucial aspect to game design, this clock concept in the frames per second. We're doing a great job of building our foundational skills so we can then jump off to make some really cool games very soon. In our next video, we'll look at how to restrict movement to our game window, because right now if we run this, I can sort of move off the screen, right? I can move my dragon off the screen here. And I definitely don't want that. So we got to somehow limit our movement. And I'll see you in that next video.
Hello and welcome back. We're going to move quick through this next video on restricting our movement because I have to keep this course under 2 hours if I wanted to make it free in Udemy. So right now our dragon moves across the screen nicely, but he goes off the screen, and we definitely don't want that. So what we need to do is when I press the left key, I also need to check to make sure that the left side of this dragon's rect is not off the screen. So like right when it gets, here, it's it's still greater than 0. If you remember, the left side of the screen is 0 right here. So right now it's probably like 10. So I should be able to move left. But once I get here, I shouldn't be able to move left anymore. And so we're going to put these conditional checks right in here where we are moving the dragon. So if the user presses the left key, and we want another condition to have to be true as well, the dragon's wrecked. And what part of the dragon's wrecked? Well, its left side. If it's greater than 0, well, then now we should be able to move left. So, right, if the dragon's right here and this is the edge of the screen, the dragon can move left, move left, move left. But then once it becomes negative, it no longer should be allowed to move left. And we can do something similar in the right direction. So I'll say and dragon wrecked dot right is less than our window width. We'll go all the way on the other side. Now up and down, remember up is the further up you go, the smaller the value. So we'll say and dragon rect dot top is greater than 0. So 0 is right here. We got to be greater than that to move up. And dragon rect dot bottom is less than our window height. And so these just extra conditionals are going to allow us to have movement restrictions on our dragon. So now you can see I am bounded to my game window. Works perfectly. I'll see you in our next video.
Hello and welcome back. Congrats on getting this far. By now you know quite a bit to begin making some cool games in Python. There is one last thing we really have to discuss, however, a crucial aspect of game development, and that's collision detection. Collisions are key aspects because collisions help us determine when a player should take damage, lose a life, when a score should increase, when they should be able to jump, when they should stop falling, just for a few quick examples here. So let's start like we always do with a new file. I'm going to save this. I will call this, and this is our 10th script, and we'll call this collision detection.py. And we'll kind of start like we always do with the basics here. We'll import Pygame, and then we'll initialize Pygame by calling pygame.init. You gotta spell it right. That's true. We'll create a display surface. So I'll do window width is equal to 600, window height is equal to, we'll do 300. I'll grab my display surface, display underscore surface, by calling pygame.display.setMode and passing as a tuple our window width and our window height. And then we'll set a caption. So I'll do pygame.display.setCaption, and I'll call this collision detection. Perfect. Now we need a game loop, right? So we'll say the main game loop here by calling a Boolean variable running and setting it equal to true. Hey, our game is running, right? So while running, what do we want to do? Right now, all we're going to do is check to see if the user wants to quit. So for event in pygame.event.get, we'll get all of the events in the event queue for this iteration of the loop, and we're going to just see if one of those is a quit type. So if event.type is equal to pygame.quit, we'll set running to false. Okay, and then we'll, of course, end the game by calling pygame.quit. Okay, so there's like our basics. Perfect. Now, we're going to have like continuous movement, and we don't want our game like moving too fast, on certain machines. So let's use declare our frames per second and create a clock here. So we'll say set FPS and clock. So FPS, I'll set it to 60 frames per second so that this while loop is going to run at most 60 times in 1 second. And to do that, we'll have to use a clock. So pygame.time.clock. All right, excellent. So there we have it. Next, I'm going to set some game values. So we're going to have our dragon that we're going to move. So I'll set its velocity. So set game values. We'll say velocity, and we'll use a constant variable here, is equal to 5, so we can adjust it later. And now let's load in our images. So load in images. So we've got our dragon, right? And that dragon's already here in this folder. So dragon image is equal to pygame.image.load, and we'll give its name dragon underscore right.png. Okay, and so that's our surface. So now we need a rect for this surface. So we'll say dragon rect. Every surface has a rect. You just have to get it. So we'll do dragon image.get rect. And then we can position it. So we'll say dragon rect dot, we'll use top left, and I'll set it to 25, 25. So the upper left-hand corner. Perfect. Now, we are going to also have another image here. We're going to have a coin image. And so we're going to try to have the dragon collide with the coin. And so let me show you where I'm going to get this. So if I come over here, I use the icon archive again. And so if I just type in coin, which one did I use? So license, I'm going to make sure that it's commercial free. And I think I use this one right here. So that's my coin that I'm using. And if we look, it's asking us to backlink it. So I'm giving you this link right here, awicons.com. So we're referencing the author of this image, so we can use it. And I'm pretty sure I grabbed one that is 32 by 32 pixels. Okay, so it's 32 by 32. Of course, you can download this right from the video, but when you download it, make sure there's our coin image that your asset is in the same folder as all these scripts for us. Okay, perfect. So now that we have that, let's load this in. So I'll say coin image is equal to pygame.image.load, and we'll call it coin.png, and we'll get its rect. So coin rect is equal to coin image.get underscore rect, and let's position it. So I'm going to put it just right in the center of the window. So we'll say coin rect dot center is equal to window width divided by 2, window height divided by 2. Awesome. So now that we have this, great. So now let's actually blit these images to the screen. So we got to do this inside of our game loop, right? So we're going to update our display. So the first thing that we have to do is fill our surface. So we'll say fill display surface by calling our display surface is the name of our surface dot fill, and we'll pass in black for there. Okay, then we'll blit our assets. So let's see, right? We'll blit our assets. So blit assets by calling display surface dot blit. What do we want to blit? Well, we want to blit our dragon image at its rect position. And we'll do the same thing with our coin. So display surface dot blit coin image at its coin rect. Awesome. We should update our display next so we can actually see these changes. Otherwise, what's the point, right? Update display by calling pygame.display.update. And then lastly, while we're here, we'll tick our clock. Right? So once we start moving these assets, they move at the speed we want them to by calling clock.tick, and then we pass in our given frames per second. Okay, so if I run this now, hopefully we're going to see our dragon and we're going to see our coin. Hey, perfect. Awesome. So there it is. So now let's add some movement to our dragon. So I'm going to use just the arrow keys here. I know I showed you like AWSD before, but you can use whatever you want, whatever control scheme you want. I'm going to use arrow keys though. Pretty much throughout the scope of the course, I think, anytime I have to use a keyboard. So let's add that continuous movement right now. So kind of like a review of what we did in the last couple of videos. So, right, we said that holding down a key is not an event in Pygame. An event is like a key press or a key release. So we can't do that continuous movement inside of this loop. So instead, we're going to back it out here. And what we're going to do is we're going to get a list of all keys currently being pressed down by saying keys are equal to, we're going to call pygame.key.getPressed. That's going to give us that list. And now we'll do our continuous movement. So we'll say if keys, pygame.keyLeft, if that value is a 1, and we're going to put movement restrictions on this, right? DragonRect.x is greater than 0. I don't want to do X, I want to do left, right? If the left side is greater than 0, then we can move them left. So both conditions have to be met, right? So DragonRect.x minus equals our velocity. There it is, velocity. Sometimes these pop-ups are a little annoying. Okay, so let's now do right. So if keys, and we'll move pygame.keyRight. So if that value is a 1, and DragonRect.right is less than window width, then we'll move it to the right. So DragonRect.x, we're going to change its x coordinate by adding our velocity. Okay, so now we got to do, what do we got to do next? Up. So if keys, pygame.key_up, k_up, and dragon rect, no, not dragon image, right? We want the dragon rect dot top is greater than 0. So that means we can move upwards. We'll do that by subtracting the y coordinate of the rect, the velocity. And then lastly, we'll do down. So if keys square brackets pygame dot k underscore down and dragon rect dot bottom, right? We're going to look at the bottom of our image now, is less than the window height. Colon, then we'll move it down. So to move it down, we'll take our dragon rect's y coordinate and we'll add our velocity. Okay, so let's just test this to make sure that this is working. There's my dragon, it's moving, and it is bound to the screen. Perfect. So now, right, I want something to happen when this dragon like collides with the coin, okay? So we got to figure out, how do we do this? How do we detect these collisions? So first, what we're going to do is let's actually draw each rect using Pygame's draw feature, using like geometric rectangles. And I think this might help us like, see some stuff here. So we are going to, inside of our game loop, after I fill the display surface, I'm going to actually, here, I'm just going to say draw rectangles to represent the rects of each object. Okay, so let's draw these. So I'm going to do pygame.draw.rect. So if you remember drawing our rectangles, we need a few things. We need, what do we need? Well, we need the surface that we're going to draw to, which is going to be a display surface. We need the color, so we'll make the dragons red, 25500, and then we need like the coordinate. Well, I'm just going to pass in the dragon rect. So this is like the top left corner of the rect, and then its width and height, and it's all right in here for the rect. And then we need a thickness, so I'll set the thickness to 1. And let's also do a coin rect. So I'll do draw.rect. So the display surface again, we'll make this one yellow maybe, because it's a coin, I guess, 2550. And we'll make this, oh, not the coin, I want the coin rect, yeah, and we'll make this one. I was just thinking, the dragon's green, so we should make this green, not red. Come on. All right, so let's run this, and now we should actually see these rectangles surrounding our game assets. All right, and so there they are. It looks kind of nice, and hopefully when we run this, right, if I start moving, the rect moves with it. And so you can kind of see, we want to see what happens when these two rects are going to collide with each other. All right, so let's see how we do this whenever these, like, essentially like these boxes overlap. So every rect has a method called collide rect, which checks for collisions with another rect. So we've got two rects, right? We've got the dragon's rect and the coin's rect. We can call this collide rect method on one of them to see if there is a collision, if the rects overlap. So let's do it on our dragon rect here first. So I'm going to do this right after I draw my rectangles. We'll do this. No, I'll do it before. Let's see. I'll do it up here. So after we move the dragon, I'll say check for collision between two rects. So I'm going to say if dragon rect, so there's the first rect, and I'm going to call the collide rect method on this. And so inside of here, I actually have to pass another rect that I want to check the collision for. Well, I want to see if it's going to collide with the coin rect. All right, if that is the case, I'm going to print the word hit, and I don't know, let's just print the word hit. Okay, let's just do this. Let's see if that actually happens. All right, I gotta actually scroll this down. There we go. So let's see, right? I'm moving, and there we go. It hits. It prints hit. So the collision is happening, which is really pretty great. And in fact, it doesn't matter which one you do, right? I could change this to coin rect, and then check for the collision with the dragon. And that should work exactly the same with this collide rect method. Okay, let's just verify that it does. Yeah, and it does. Okay, that makes perfect sense. But I'm controlling the dragon, so I mean, I feel like it makes more sense to check if the dragon is colliding with the coin. So we're going to change that back. Coin rect. There we go. Okay, so now let's do something just a little different here. When I collide, I want to move the coin. Okay, I want to move the coin to like a random place on the display, almost like I'm trying to like collect it. So to have a random place, I need to import the random library. So I'm going to come back up here where I imported Pygame. I'm also going to import random. And now let's change the rect position of the coin. So here I'm going to do coin rect dot, we'll say the left position. And to do this, I'm going to create a random integer, so random.randint. And we're talking about the left side of the coin. So where can I put it? Well, I can put it all the way at 0. I can put the left all the way at 0, or the far left-hand side of my window. But then on the x coordinate, right, I want to randomly position it on the x-axis here. So the left can be 0, but if I put the right at window width, it's going to be off the screen because we're talking about the left side of the image. So what I need to do is do the window width minus the pixel size of the coin. And did I get 32? Let me check. Is this I got to go to properties, I think. I can right click properties and details. It is 32 pixels big, so 32 pixels. So we'll subtract off 32 here. And so that will make sure that it stays within the window. So the left side, instead of being like right here at the edge of the screen, it'll be over here. All right, perfect. And so now let's also do something similar with we'll do the top. Okay, to position the top is equal to random.randint, and we can say the top can be at 0, or it can be at window height minus the 32 pixels. Now, I use the words left and top so that we can clearly see why we have to subtract off the 32. But we can also say X here and also Y. And I think that that's a little bit more descriptive here. X is the same as left and Y is the same as top when you do this. Okay, so if we run this now, we should hopefully see when our rects collide, the coin moves. And it does. That's kind of nice. So it's like we're like sort of chasing the coin here. And almost kind of beginning to see some semblance of gameplay. So this is really a pretty good place to stop. I'm really happy here. I think this is like I said, I think this is a great place to stop with our, actually, not just this video, but like our series of introductory videos overall. Moving forward, we're going to begin to code some games that build upon these skills and concepts that you've learned in sort of like this introductory set of videos. For now, maybe what I challenge you to do is to incorporate some of these concepts actually incorporate some of our other concepts into this program here. So like we've just got images. Can you add text? Can you, to keep track of like how many times you've collided with the coin? Can you add sound effects so that every time you collide with the coin you hear a sound? Can you add background music? Could you change this to mouse controls? So instead of using the keyboard, you have to like click and drag the dragon. These are all great things to try on your own to make sure that you have a real ownership of the skills that we've introduced up to this point here in these videos. I hope you've enjoyed these videos so far, and I really can't wait to build some games with you in our upcoming set of videos. So I will see you then.